And that is a great question. Why do you often see 95% confidence intervals used? I'm actually going to have you explore an AI-generated answer to why they're so prevalent in your homework. But the quick and easy answer is you do not have to use only 95% confidence. By the end of this video, we'll know what that means, at least for starters. I got a great quiz for you to do this week that actually rips apart the definition of what 95% confidence actually means using an interactive kind of activity. But you don't have to use 95% confidence. As a matter of fact, let me real quick build a spreadsheet to show you which other values you can use for that multiplier besides that 2.
Okay, my friends. So what we're looking at here is 3 things. First of all, the bell curve up top. That's just giving you a visual of the area that we're going to edit down here in this little gray box down here. Okay, so 95% confidence, multiplier 1.96. I know we said it was 2 before. That's because it's very often rounded off to 2 because it's an easy number to remember. It's technically 1.96. You have to go a little bit higher with the confidence to get it to be exactly 2. I think it's like 95.5%. Yeah, so, but generally speaking, and I want to start right now by saying you're not going to memorize these numbers. We're going to be using technology to generate these. I'm very saddened that the state of Oregon changed Stat 243 years ago. I used to have an entire week devoted to the bell curve in Math 243, and there's just no room for it anymore because they put so much more in Stats 243. So this was part of a larger discussion in the old Math 243, but whatever, it's gone now. So anyway, 95% confidence. Your interval is going to be that wide, in theory, and the multiplier you would use on the standard error would be 1.96. Okay, let's suppose you want more confidence. Let's suppose you want to go to 96% confidence. Well, if you watch that dark blue area up there, it just got wider because now you are more confident in your estimate. Your interval is going to be wider. Using the fish analogy or the tank analogy or something like that, you've given the parameter more room to roam, so you're more confident you're going to trap it. You go up to 97%, 98%, 99%, 99.99%. Oh, excuse me, that was just 99.9. 99.99%. And notice, even though the graph appears to be completely shaded in now, we're only out not even 4 standard deviations. Now, you can't go to 100% confidence. You can't. It's going to break Excel because the mathematics doesn't make any sense with 100% confidence. And again, I wish we had more time to talk about the normal distribution as to why, but you can get very close to that 100%. You can get out to 99.9999% confidence, for example. Now you're out almost 5 standard errors. You could also go below 95%. A very common number to use is 90%, which is about 1.64 standard errors. 85%, I've never seen it used, but you could go 85%. This is kind of an interesting one, and you might remember this from your study of standard deviations. 68% is just about 1 standard error. Just about 1. 68%, 1 standard deviation. That was one of those numbers we learned about in the empirical rule for standard errors. Now, you do not have to memorize these numbers. You don't. But just realize if you see 95% confidence, they are using a multiplier of 1.96, conversationally known as 2.
You can use whatever multiplier statistically you choose to use. As we go through this course, by the end, we'll have a slightly better feel for when you should change confidences. You can't do too much in a 10-week introduction to statistics course, but sometimes it actually does make sense to raise confidence or lower confidence depending on situations. And I do want to talk about that, not right now. We'll talk about that later once we kind of get inferential stats kind of under our belt. The big idea of confidence. It's slightly tricky, but here's what I'm going to use 95% confidence as my baseline for this, but you can extend it to any percentage. A 95% confidence interval, once you create one, we're going to create lots of them in the coming weeks. Once you create a 95% confidence interval, what does the 95% confidence part mean? It means Your interval is one of many intervals that could have been created based on random sampling. Every time you do an experiment, you get different random sample results. Even if you do the experiment the same way, the results you get are different. Out of every 100 possible samples drawn, if they're all constructed at 95% confidence, then 95 out of the 100 intervals are going to actually catch the population parameter you're looking for. The question is yours one of those? Well, 95% confidence means 95 of them will and 5% won't. So the odds are with you there. Could you increase the likelihood that you trap the parameter? You can raise confidence, as we saw. Use a larger multiplier, which makes the interval wider. What's the disadvantage of that? Well, I'm going to have you analyze that too in the homework. Why would you want to make the interval narrower? I don't want to get into that too much right now. We'll talk about that more later on in the course. But the idea of confidence is it is a way of forming a range of values that attempts to capture a parameter in the general population you're looking for. And I think that gives us enough to wrap this day up and then look forward to next week when we actually start calculating these things, looking back to spinning pennies that we did in one of the earlier lessons. All right, that's enough for right now. Go try to